Getting an AI agent to act intelligently in the real world, well, that's one of the toughest nuts to crack in the entire field. But a really fascinating new paper from Meta and The Ohio State University introduces a powerful new method that might just change the game. Okay, let's dive into this. So, this is the real question, isn't it? I mean, think about it. If an AI is trying to navigate a website or use a new app, there's no person standing over its shoulder giving it points for a good click and taking them away for a bad one. So how on earth can it learn to get better on its own? This new research has a surprisingly elegant answer. All right, here's our roadmap. We're going to start with the big problem in AI training today. Then we'll introduce this new solution called early experience. After that, we'll get into the nitty-gritty of how it works, check out the pretty impressive results, and wrap up with why this is such a fundamental leap forward. To really get why this new method is so important, you first got to understand the two main ways we currently teach AI agents. And honestly, they're both powerful, but they're also deeply flawed, and they sit at two totally opposite ends of the spectrum. So on one hand, you've got what's called imitation learning, or IL. This is pretty much what it sounds like. The AI agent just watches a human expert and copies their exact moves. It's like following a recipe perfectly, which is great until, you're missing an ingredient or your oven is slightly different, then the whole thing falls apart. On the other extreme, you have reinforcement learning, or RL. This is just pure chaotic trial and error. The AI just tries random stuff over and over and over, hoping it eventually stumbles onto a reward. It's like a chef who's never cooked before just throwing random things in a pan, hoping something tasty comes out. It can work, eventually, but man, is it inefficient. So here's the bottom line. Imitation learning is brittle. It just can't handle new situations it hasn't seen before. And reinforcement learning, it's often a total non-starter in the real world because most tasks we want AI to do, like booking a flight or filling out a form, don't have a simple point system. There's no reward to give. And that leaves us with this huge, gaping hole in how we train AI. And this is where the new paper comes in and does something really clever. It proposes a third way, a kind of brilliant middle ground that builds a bridge between those two extremes. They call it early experience. Okay, so at its heart, early experience is all about letting an agent learn by asking what if. It comes up with its own ideas, tries them out, and this is the absolute key. It uses the outcome itself as the lesson. It doesn't need a score. It doesn't need a reward telling it, good job. The consequence of the action is the entire lesson. Let's go back to our chef. Imagine they know the expert recipe, but they get curious and think, what if I added just a little more chili powder? So they try it, they taste it, and they immediately go, whoa, okay, that's way too spicy. Now I get why the original recipe had that specific amount. The agent learns from its own curiosity, from its own what-if moment, without anybody needing to judge the final dish. So how does this actually work under the hood? It sounds cool in theory, but how do you implement it? The researchers came up with two main strategies to make early experience a reality. Let's break them down. The first strategy is called implicit world modeling. So here's the deal. The agent sees what the expert did, but then it thinks about doing something different. Its whole job then becomes predicting the outcome. Okay, what will the screen look like after I click this other button instead? Just by doing this over and over, the agent is forced to build its own mental map of how its world works. It starts to understand cause and effect, the basic physics of its digital environment, all on its own. You can almost imagine the agent having this little internal monologue, right? It's thinking, okay, the expert picked the blue shirt, but what if I click the red one? Oh, the red one's over budget. I get it now. Lesson learned. I need to pay attention to that price constraint. It learns the reasoning behind the expert's choice. And that brings us to the second and maybe even cooler strategy, self-reflection. Here, the agent doesn't just see a different outcome. It's trained to actually write out an explanation in plain English for why the expert's move was better. By forcing it to articulate the reason, you're not just teaching it facts, you're teaching it how to reason. It's a huge step up. The theory's fantastic, right? It's intuitive, it's elegant. But does it actually hold up when the rubber meets the road? Well, the researchers put it to the test across 8 really different and complex digital environments to find out. And the results were, well, they were pretty great. On average, agents trained with this early experience method showed a 9.6% absolute improvement in getting the job done. Now, for those who don't follow AI benchmarks, let me tell you, getting a nearly 10-point jump across 8 different domains, that is a massive deal. But this next number might be even more important. They saw a similar 9.4% improvement in what's called out-of-domain generalization. In simple terms, this means the agents were way better at handling situations they had never seen before. They became more robust, more adaptable, which directly fixes that core weakness of just copying the expert. But for me, this is the real kicker. After training the agents with early experience, the researchers then applied traditional reinforcement learning on top. And as you can see clear as day in this chart, the agents that got that early experience foundation ended up reaching a much higher level of performance. This proves it's not just a better way to start. It's a more powerful launchpad that makes all future learning that much more effective. So yeah, the performance gains are clear. But to really appreciate what a breakthrough this is, we gotta look past the numbers and think about the bigger strategic advantages this whole idea brings to the table. There are 3 huge takeaways here. First, this method is incredibly data efficient. In some of their tests, these agents got better results using only half of the expert data. That's huge. Second, it scales. The bigger and smarter the AI models get, the bigger the benefits of this approach become. And finally, it gives us that practical, scalable bridge we've been looking for, a way to finally move beyond just mindlessly copying humans to actually learning from experience. Okay, so let's tie this all together with a bow. This new paradigm, it really feels like it could be a fundamental shift in how we go about building autonomous AI agents. So let's just recap. We started with this dilemma, right? AI agents were stuck between 2 imperfect choices, imitation learning, which is brittle, and reinforcement learning, which is often just not practical. The solution that this paper puts on the table is early experience. It's this whole new way of thinking that lets an agent learn from its own what-if moments, using the outcome of its own actions as the lesson, all without needing some external reward. We saw the 2 core ways they do this: implicit world modeling, which teaches the AI the rules of its world, and self-reflection, which teaches it the logic behind good decisions. And the proof is in the pudding. This makes agents better, more robust in new situations, and way more efficient with data. But most importantly, it acts as a powerful new foundation, getting these agents ready for what you could call the era of experience, where they can truly improve all on their own. Hey, if you enjoyed this deep dive into the guts of how AI actually learns, do us a favor and hit that subscribe button for VibeDoc. We're all about breaking down the complex stuff so you don't have to. We'll provide the intellectual safety helmet. This research really opens up a ton of new doors. So I'll just leave you with this question to chew on. Now that AIs can finally learn from their own curiosity and their own mistakes, what kinds of previously impossible challenges are they going to solve next? Thanks for watching.